Hi, this is Alana, and I'm in a group with Francisco and Shin Yu, and we'll be discussing a discontinuous cost function optimization problem. The problem example that we're using pertains to Amazon locker locations. So we're going to have 30 potential locker locations that need to be used in a given area and 300 customers associated to that area. All 300 customers need to have access to a locker. Our objective is to minimize the amount of money it takes to do this, and there is a initial cost for each of the lockers being set up to be $500,000, and this is only a one-time investment, meaning that it doesn't cost any money for the locker to stay in that location. And we also have a cost for the distance the customer travels, which is $100 per kilometer, and we want the customer to only have to travel less than 30 kilometers to reach a locker, and we have only one locker per customer.
When trying to construct this problem, we decided J would be the customer and I would represent the locker location. And so we would have a loop for each. And so in the first loop, it would look at the best distance for a certain customer. So it would have like a competition basically, meaning it would look at the current distance and then look at the best distance. And then if the current distance is less than the best distance becomes that current distance. And then that locker location chosen will equal that I. And then the customer distance will equal the customer distance plus best distance. And then for the second loop, it'll be assigning the locker location to the certain customer. So it'll be assigning that locker location that closest to the customer. So then you can put it into the cost function and minimize the total cost of the distance traveled. For this cost function optimization problem, we used Microsoft Visual Studios to write some C++ coding that uses genetic algorithm and trying to find the most optimal way to assign a locker to a customer and find the least cost in doing so. What we're doing in Visual Studios is basically trying to solve a Amazon locker problem, and we're using C++ to do this, and as well we're using a genetic algorithm to find the best possible optimization for this cost function. So what we want to do first is include all these libraries in here so that the code can work, and then have the location, customers, best distance, customer distance, locker chosen, total cost as integers, and set them either 0 or n equals 40. And then we have the best distance as a large number. So as we go through, as the code keeps running, it will find a best distance that is lower than that large number. So inside of the int main, what we're doing is that we're basically creating a distance matrix of 40 by 360. And initially everything is all zeros inside of there, but then it's going to call a file and open it up, read it, and then it's going to take all the values and place them and replace the zeros inside of the disk matrix. So as you can see that the 40 locations and 360 customers. So here I'll show you how it looks like. So these are all the distances. And then what we'll do after that is that it's going to display the rows and columns of that distance matrix. And then here you see the number of places in the matrix. Then what we're going to do is get a random number, and it's going to generate a number 1 through 30 for the locker array, and then get a number from 1 through 30, and then creates an array from 0 to 29. And as you can see, the function sets the seed of the random number generator algorithm and generates different sequences. So then basically what the rest of the code is doing is that it's gonna pick out a random number or a random locker, and it's gonna try to find the closest customer to it within 30 kilometers, and then it will assign it, but it won't assign the locker to the same customer. So if a customer already has a locker, it won't assign it to that same customer, and it will move on to the next customer and find the best placed locker for that certain customer. And then after all of this is done, um, the sum of the total distance is made from the array. And then as you can see here, the best distance is chosen each time, and then it adds another locker. It adds another locker that was chosen and sums that up. So now down here, you'll see that the total cost is 50,000 times the lockers chosen plus 100 times the customer distance. So the total distance in the array. And here we'll see out the total cost and the total number of lockers chosen. So now we'll run it. And it should be showing, yeah. So it'll show the distance matrix, and then it'll show the lockers chosen for this problem, this optimization problem. It's kind of recursive. But then it should show all the lockers chosen, and here you see the total cost is 1,020,000. And yeah, this is the Amazon locker problem.
So how can businesses use these results? For our example, Amazon can use the results by comparing different total costs to perform the service that they do. They can check what locations are the best for each customer. Businesses are able to recognize how to efficiently deliver a solution that will benefit both them and the customer. And how can this technology be used in the business today? From our example, now that Amazon is finding ways to reach all customers, whether by drone, truck, or person, they can now try out different algorithms, such as the genetic algorithm, tournament, a search method, to improve all traveling costs problem.